everybody. Welcome back from break. Hope you had a relaxing week off. We're going to get back to it. Let's see what we remember about the properties of parallelograms, rectangles, and rhombuses. Also, let me put out there that the plural for rhombus is both rhombuses and rhombi. So we'll go back and forth between the two just in case you were wondering which one's correct. Okay, parallelogram. Here's our basic parallelogram. Remember we said that there are 5 major properties, including the definition. So the definition is that the opposite sides are parallel. Another property is that the opposite sides, this one too, opposite sides are congruent. We also know that the opposite angles are congruent, these guys and these guys. Another property we know about the angles is that the consecutive angles here are supplementary. So if this one here is 60, then that one would have to be 120 because these guys next to each other have to add up to 180 degrees. Last property for a parallelogram is that the diagonals bisect each other. I'm actually going to put a little guy over here because otherwise this picture is too clouded up. But here are the diagonals of a, make this one a little darker, of a parallelogram. Bisecting each other doesn't mean that they're the same size, because this guy here does look a lot longer than the other one. But bisect means that this one is cut in half at the center point, and this one is also cut in half. So now, those are the properties of a rectangle, and then we said, okay, well now we have, let's see if I can do this. Oh look, there it is! Here's our rectangle. So now we have a rectangle, and the rectangle is a quadrilateral with 4 congruent sides. Well, if all 4 are angles, if all of the angles are congruent here, then they are all 90 degrees, and these opposite ones are clearly congruent. They're both 90. These opposite ones are clearly congruent. They're 90. And if opposite angles are congruent, by the way, all of these are also ways that we can prove we have a parallelogram. This is a parallelogram. So all of these properties also hold true for a rectangle. So we know that, get rid of the stuff underneath, we know that all of the properties for a parallelogram hold true, so that's 5. All right angles, that's our definition. And the last guy is that the diagonals are congruent to each other. So we remember this picture. If we're going to draw a diagonal picture for a rectangle, it looks like this. But these guys are congruent and those guys are congruent, but if I have this and I know that these 2 diagonals are congruent, then these 2 little pieces are the same also. So that's what it would look like if we're marking the diagonals for a rectangle. All 4 of these little pieces are congruent to each other. Now we can move on to the rhombus. Okay, so here's a rhombus. So a rhombus is a quadrilateral. By definition, all 4 sides are the same. But if we have all 4 sides the same, then clearly these opposite guys are congruent. And these opposite guys are congruent. And if we have opposite sides congruent, then we have a parallelogram. So now I know that a rhombus contains all 5 of these properties plus more. The definition itself, which is the 4 congruent sides. And then beyond that, we can draw in these diagonals. So let's draw them in. First thing I'm going to notice is that these diagonals are perpendicular to each other. So now what I've created are 1, 2, 3, 4 right triangles. So I have 4 right triangles, and because, by the way, it is a parallelogram, these diagonals bisect each other. These are not all congruent pieces because it's not a rectangle. Parallelogram. So now what I have, oops, 2, 3, 2, 3, because I have to mark them all differently. So these 4 little baby triangles all congruent to each other. When that happens, I can talk about these little angles. The third and final property for a rhombus is that this diagonal here cuts these opposite angles into smaller pieces that are congruent to each other. So these 4 triangles here have this same small angle here, and this way, these 4 angles are all the same. Diagonals bisect the opposite angles. So these 4 small angles are the same, and on the left and right, these 4 small angles are the same. Okay, so I'm going to move on, and I'm going to do the problems that use the properties. So here it is. Hopefully you guys have this one out also. At any moment, pause it if you guys want to try these by yourself. First one. So here we have a rectangle. As soon as I have a rectangle, I know all the properties for parallelogram work, and also all of these angles are 90 degrees. I also know that the diagonals are congruent, and when I talk about the diagonals being congruent, that means that all 4 of these little pieces, 1, 2, 3, 4, they are all congruent to each other. So a lot of times when we have rectangle problems, they'll kind of zero in on a couple of those properties. Rectangle A, B, C, D has to go around in that order. Well, here we have AE. This piece right here, whoops, is 4x plus 5, and DB, that's this entire one. That is 10x plus 4. Since we're talking about diagonals, that's what I'm marking. And remember we said all of these pieces are the same. So this one guy is that. But I know that 4x plus 5 is also here, is also here, is also here. So this entire thing that is 10x plus 4 is 2 of these. So the equation that I can write, 10x plus 4, is equal to 2 of these. You can write 2 and then distribute, or you can do 4x plus 5 twice. 8x plus 10. Minus 8x minus 4, and x is equal to 6. So, 6 divided by 2, x is equal to 3. So here's 3. I can plug that back in. Ooh, EC. EC I don't know, except that I do know it because all 4 of these little pieces, remember we said, are the same. So if I plug x in for this guy, 4x plus 5, I'm going to new color. 4x plus 5, so that's 312 plus 5, that's 17. That means each of these guys here is 17, 17, 17, 7. I'm going to write it all in because I'm positive. So EC is 17. Now if I want AC, 17 and 17, 34. Moving on to number 2. We have a rectangle here, so in this rectangle ABD, let's write it in. ABD, x plus 14, and 3x plus 4 is DBC. Okay, so they give me these 2 angles here. They tell me it's a rectangle. Because it's a rectangle, I know, right angle. I'm going to add these 2 guys, and I'm going to set it equal to 90 degrees. So x plus 14 plus 3x plus 4 is equal to 90. 4x, that's 18 minus 18, 72, and x is equal to 1, 8. This is just a simple algebraic equation. You guys can solve that on your own. X is equal to 18. Now we want to go back and find the measure of angle DBC. So we're going to plug it in. I have no idea. Let me grab this guy over here. May as well use it, right? So let's do 3 times 18 plus 4. By the way, DBC, you can get it right from here also. 3 times 18 plus 4. And we can double check ourselves because we're going to do 18 plus 14, 32, and 58 plus 32, yes, that's equal to 80 plus 10, so that's 90 degrees. Moving on. Let's go down here. Number 3. So as I look at number 3, I want to find the length of this diagonal. Ooh, it's a rhombus. Rhombus tells me a lot of things. It tells me this. It's one thing it tells me. It also tells me I got perpendiculars here. Maybe that's going to be important. We'll soon find out. Perimeter ABCD. ABCD is 20. Well, if the whole perimeter is 20 and all the sides are the same, well then each of them must be 5. I'm going to do 20 divided by 4. Each side is equal to 5. BE, well that's this little guy here, and that's equal to 3. I also know that a rhombus is a parallelogram, so if that is 3, then this side down here is 3. Maybe that's going to help me, maybe not, but I do want to know something about this diagonal. Remember, we learned triangles for a reason. Triangles show up everywhere. So here is a right triangle. We want to know what that side is. So that's 3, that's x, and that's 5, and it's a right triangle. 3 squared plus x squared is equal to 5 squared. Maybe a lot of us already see the 3, 4, 5 triangle happening. So this is 4. Remember, that's the left side. This guy is also 4 over here. So where are we? AC is equal to 8. Last one. We want to find the measures of all of these numbered angles. Okay. And I don't tell you that it's a rhombus. I do want to tell you it's a rhombus. So let's put that in there. Okay. So we can either mark all the sides the same or tell you that it's a rhombus, but you do have to know that. If that's 60, then that means that all of these, see this diagonal? In a rhombus, it bisects the opposite angles. So this is 60, this is 60. Over here, 60 and 60. I also know that all of these guys in the middle, 90 degrees because the diagonals are perpendicular. If that's 90 and that's 60, subtract from 180, 30 is left over, and all of these are the same. All 4 of these triangles are congruent, same sides, and we saw that over here, and they also have the same angles.